Okay, working on this homework for 3.7, L'Hopital's rule. So L'Hopital's rule is just a fantastic rule. We use it to calculate limits. So if we have a limit, let's say x goes to something, it really doesn't matter what it's going to, and we have some function on top and some function on the bottom, and if this limit approaches 0 over 0, or if it goes to positive or negative infinity over positive or negative infinity, we know normally we have to do some sort of algebra or some sort of trick in order to get that to work out. But L'Hopital's rule says that what we can do is take that and now do the limit as x approaches whatever it was going to of the derivative of the top divided by the derivative of the bottom. Not the quotient rule, just take derivative of top and bottom separately. And whatever that limit is, the answer to that is also the answer to this. And then I probably in my lectures and my videos, I mention this, but I'll mention it again. Question becomes, well, if this is the way we can calculate limits, and we've already done limits before and they were kind of hard sometimes, why not just give you this rule to begin with? Well, the reason is because we started this class with the idea of the limit. From the limit, we established the idea of the derivative. So we couldn't have done the limit because we didn't know what the derivative was yet. Now that we know the derivative, we can actually come back and use it to calculate limits. So we got to get the horses in front of the carriage, so to speak. Can't get it the other way around. So let's start this problem off. So let's first of all let x go to 1 and see what happens. If x goes to 1, I get 1 to some power. 1 to any power is just 1. And then if x is 1 there, that's minus 5a. And then I have plus 5a, and then I have minus 1. And then on the bottom, if x is 1 there, you get 0. 0 squared is 0. So the top things cancel. You get 0 over 0. So in the limit, this thing is approaching 0 over 0. So what we're going to do is apply L'Hopital's rule. And when we do it, you can put an L here for L'Hopital. Some books use an H for L'Hopital, but I'll use L. And that means we're going to rewrite the limit. X approaches 1. And we're going to do separately, not quotient rule, the derivative in top and bottom. So on the derivative top, we have 1, 2, 3, 4 terms. We're differentiating with respect to x. The derivative of x to the 5a is power rule. The 5a comes out. X to the 5a take away 1. So reduce the power by 1. The derivative of negative 5ax, x is our variable, derivative of x is 1, negative 5a is a constant. And then derivative of 5a is 0 because it's a constant, derivative of negative 1 is 0. So that's derivative of top. And now derivative of the bottom, the 2 comes out. This is chain rule. Okay, we're doing chain rule, and this 2 comes out, x minus 1 to the first power times the derivative of what's in there, which is 1. So now what we have is to look and see what happens if x approaches 1. So again, if x approaches 1 here, 1 here, 1 to any power should be 1. So on the top, this part's just a 1. So we get 5a minus 5a over. On the bottom, if we plug 1 in here, we still get 0. So on the top, it's going to 0. The bottom is going to 0. So we're still getting 0 over 0, which may appear to be a problem. However, L'Hopital's rule says that you can try and do it again. So what we're going to do is we're going to apply L'Hopital's rule again. Limit x is approaching 1. We take the derivative of the top here. So derivative of this right here, the 5a minus 1 comes out. There was already a 5a out there, so I put it next to it. The power up here, right, comes down again, so I subtract 1 from that. So I have x to the 5a minus 2 this time. And then the derivative of this, that's a constant, is 0, so nothing. Then the bottom, remember this on the bottom was really just 2 times x minus 1. That's the same as 2x minus 2. Derivative of that is just 2. And now let's let x go to 1 again. If x goes to 1, remember this piece here will be a 1. 1 to any power is 1. So all we get is 5a on top. 5a times 5a minus 1 Then over on the bottom is just 2. And so we don't get 0 over 0. This is our answer. This is the limit. Very nice. Okay, so let's look at this one. Checking real quick. Let's let x go to 0. Cosine of 0 is 1 minus 1. And then if that's 0, that's just plus 0 there. All over, if x goes to 0, the bottom is 0 to the 4th, which is 0. So we do get 0 over 0. Because we get 0 over 0, applying L'Hopital's rule, limit, x approaches 0. Derivative of the top. Derivative of cosine x is sine x. Got that one. Derivative of 1 is 0. Derivative of 1/2 x squared, the 2 comes out. Half of 2 is 1, so we just get x. And on the bottom, we get 4x cubed. Now, try let x go to 0 again on top and bottom. Sine of 0, right? Sine of 0 is going to give us 0, and then 0 here, and on the bottom 0. So we get 0 over 0 still. So let's try it again. Limit x approaches 0. And now derivative of sine of x is cosine x. Crap, you know what? I just realized derivative cosine, I didn't put negative sign. Oops. That means this is negative cosine. Okay, so derivative of negative sine x is cosine x. And then derivative of x here is going to be 1, so plus 1 over. And now take derivative on the bottom, we get 12x squared. So 3 came out, hit the 4, power came down. Let's let x go to 0. Okay, if we let x go to 0, cosine of 0 is 1, but then it's negative, so negative 1. I have negative 1 plus 1 on top. On the bottom I get 0, so we still have 0 over 0. So I apply L'Hopital again. Limit x goes to 0. So now at this point I do L'Hopital. I take derivative of top again. Derivative of cosine of x is negative sine x, but then I already had negative, so it'll be sine x. And then derivative of 1 is 0. Then on the bottom we get 24x. And now, if I try and let x go to 0, the top, sine of 0 is 0. The bottom is still 0. So I still have 0 over 0, but we're making progress. L'Hopital again. Limit x goes to 0. Derivative of sine x is cosine x. On the bottom, derivative of 24x is 24. Now let x go to 0. Cosine of 0 here is 1. And on the bottom, the 24 stays. So we just get 1/24. So that is the limit. Okay, let's check this one out. We have limit x goes to 0 of cotangent 2x sine 4x. Let me just first rewrite this. Cotangent of 2x is the reciprocal of tangent. Tangent is sine over cosine, so this is cosine 2x over sine 2x times sine 4x. You could say over 1. Or, better yet, why don't we just put it all like this? Okay. Now, if I let x go to 0, cosine, this will become 0. So cosine of 0 is 1. Sine of 0 is 0. Sine of 0 is 0. So I do get 0 over 0. I apply L'Hopital. Limit x goes to 0. Now, the numerator, I take the derivative of the numerator up here. Oops, I didn't mean to do that. Whoa, what the heck? 2x, 4x. The numerator is a product. So when I take derivative, I have to do product rule. Derivative cosine 2x is negative sine 2x. Chain rule, times 2. Then times the second one, sine 2x, sine 4x, sorry. And then plus the derivative of the other one, derivative of sine x is cosine, or derivative of sine 4x is cosine 4x times 4, and then times the first one, which is cosine 2x. And this is starting to look ugly. Over sine 2x. Sorry, derivative of the bottom, which is cosine 2x, and then chain rule times 2. So I did the derivative of the top, which was a product rule. I did derivative of the bottom, which was this. Again, not doing quotient rule. Don't mix that up. Now let's let x go to 0. Okay. If x is 0, this is 0. Sine of 0 is 0. That kills all of this off. And then this is 0. Cosine of 0 there would be 1. Then times 4, and then this is 0, so cosine of 0 is 1. So that's just 1 times 4 times 1, which is 4. So 4 on top. And then this is 0. Cosine of 0 is 1. Then times 2 is 2. So you get the answer is 2. So we only have to do L'Hopital one time there. Okay. Quick pause. Okay, let's take a look at this one. We're letting x go to infinity here. So before I do this, I'm going to rewrite this to help us see it. It's x to the 8th over e to the negative, I'm sorry, the negative's gone. I dropped it down, that's why I did it. And that's too thick. It's x to the 8th over e x to the 7th. So now what I'm going to do is let x go to infinity. Infinity to the 8th power is infinity. And then e to the infinity is still infinity. So they're both getting infinitely large. So I have infinity over infinity, so I can use L'Hopital. Now, the derivative of the top is 8x to the 7th over derivative of the bottom, so be careful here. Derivative of e to something is itself, times the derivative of what was up there. Derivative of x to the 7th is 7x to the 6th. Now, before I do anything else, let me cancel some stuff here. I've got x to the 6th cancels out with this. I'll still have 1x up here. So I have limit x goes to infinity of 8x over 7 e to the x to the 7th. And again, if I let x go to infinity, 8 times infinity is infinity, and then e to the infinity is infinity times 7 is still infinity. So I have infinity over infinity. So that means I'm going to use L'Hopital again. And what you're going to see is on the top, derivative of 8x is 8. And then derivative of the bottom, the 7's a constant. Derivative of e to the x to the 7th is itself, so that times derivative of x to the 7th, which is 7x to the 6th. And now I'm going to let x go to infinity. So on the top I get 8. On the bottom I get 7 times infinity again is infinity. So what's happening here is we have a fixed number, and the bottom is becoming infinite, and that's going to go to 0. So the answer here is 0. Notice the reason this happens is because it's a fixed number on top over infinity. We don't have infinity over infinity anymore. Okay, so check out this one. We're doing the limit as x approaches 0 from the right. So let's be careful here. So let's first try and figure out what's going on. The sine function looks like this. As we approach 0 from the right, we're approaching 0. So it is approaching 0 here, times, now natural log function looks like this. And so as we approach 0 from the right, our natural log function is taking off to negative infinity. So this is becoming negative infinity, and we're multiplying those. So what's happening is we have something that looks like 0 times negative infinity, or just infinity. It doesn't matter. You could put your negative out in front, like a negative 1 times that. Anytime you have 0 times infinity, that's an indeterminate form. That's just as bad as this or this. In the limit, we don't know what's happening here. We have to do some work. So here's what we're going to do. What we're going to do, anytime we see 0 times infinity like that, we are going to take one of these and drop it down as in the denominator. So watch. I'm going to rewrite this as limit x approaches 0 from the right. I'm going to leave the natural log up on top. I'm going to drop the sign down as 1 over sine x. Now I have not changed the problem because I could just flip the sign and bring it back up, and that would just be sine x natural log x. However, this is limit x goes to 0 from the right of natural log x over 1 over sine is cosecant x. So now, if you let x go to 0 again, we already know that this goes to negative infinity. Cosecant, remember, is 1 over sine, and if we plug in 0 here, we get 1 over 0, and since we're approaching from the right, that will be approaching infinity. So what we get is infinity over infinity. Now that's a good thing, because when we have infinity over infinity, we can use L'Hopital's rule. We cannot use L'Hopital's rule when we have this. We have to first convert it so we get something like that. That's why you always are going to take one of them and drop them on the bottom. So we are now going to have limit x goes to 0 from the right. The derivative of the top is 1 over x. The derivative of the bottom is negative cosecant x cotangent x. And now, let me see if I can't clean this up a little bit. Kind of out of room. This is the limit x goes to 0 from the right of 1 over x over, okay, cosecant is negative 1 over sine x, and cotangent is the reciprocal of tangent, so tangent sine over cosine, so this is cosine x over sine x. So this is equal to the limit as x approaches 0 from the right of 1 over x over negative cosine x over sine squared x. I'm going to take this fraction here, I'm going to flip it up to the top and make it sine squared x over negative cosine x. Okay, so at this point I've got quite the mess. I have equals limit x approaches 0 from the right of sine squared x over negative x cosine x. Now, if I were to go and let x be 0 right now, I'd get 0 on top, sine of 0, 0, and on the bottom, that x would make the 0 side of 0 on the bottom. So I could use L'Hopital again here. However, I see that if I do use L'Hopital, I'm going to have some pretty ugly stuff happening. So I'm kind of thinking, do I want to, or do I want to show you something else? Let me show you first what my instinct would do here, and then we'll try L'Hopital if it doesn't work. Because we could use L'Hopital again right now. I'm going to split the top up as sine x times sine x, and then over on the bottom I had a negative x here, and then over here I have cosine x. And if I look at these separately, right, I know that this is not a problem, right, because the top goes to 0, the bottom goes to 1, and that's just 0. But this one, I have to think about what happens here. I get 0 over 0. So why don't I just do L'Hopital on just this piece right here to see what really happens to it. So L'Hopital on just that one piece, derivative of top is cosine x, derivative of bottom is negative 1. And now when I do the limit as x goes to 0 from the right, this one we already knew this one was going to go to 0, and this one right here, cosine of 0 is 1, we get negative 1. So this is all turning out to be negative 1 times 0, which is going to be 0. Now, that's if you wanted to do it by splitting it up. However, I could do this instead. I could have used L'Hopital. So let me show you that. If I were to have done L'Hopital here, I would do limit x goes to 0 from the right. Derivative top is 2 sine x cosine x. That's chain rule, right? 2 comes out, then sine to the first power, and then derivative sine is cosine. The bottom is a product rule, so I get negative 1 times cosine x plus, and then derivative of cosine, negative sine x, then times the first one, which is negative x. And now if I let x go to 0, I get this becomes 0, and then I have 2 times 1, right? This is 2. This becomes a 1 if x is 0, and then that becomes 0. So multiply them, you get 0 on top. And then these two together, remember cosine of 0 is 1, you get negative 1, and then plus, and then over here sine of 0 is 0, then times 0, so you get 0. But that's just 0 over negative 1, which gives you 0. So get the same answer. Okay, find the limit. As x goes to 0. So cosecant of 0 is 0. Is becoming infinite, minus cotangent of 0 is becoming infinite also. Now another way to see that is, let's just rewrite this limit x approaches 0. Cosecant is 1 over sine x. And cotangent is cosine x over sine x. So as you can see, as x goes to 0, you get 1 over 0, 1 over 0. They're both becoming infinite, or the limit. You could even say the limit doesn't exist. But check that out. They both have the same denominator. So why don't we just put those together? 1 minus cosine x over sine x. And now, if we do it this way, the top is 1 minus, as x goes to 0, you get 1 here, so you get 0 on top, and on the bottom you get 0. So we have the form we need for L'Hopital. So L'Hopital, I'm going to take derivative of top, derivative of top, derivative of 1 is 0, derivative of negative cosine x is going to give me positive sine x. And then derivative of the bottom is cosine x. And now let x go to 0. The top goes to 0, but the bottom goes to 1. 0 divided by 1 is 0. So we get 0. Okay, last one. Find the limit. Use L'Hopital's rule or something else. So x goes to infinity of 3x minus natural log x. So for this one, let's just see what's happening as x goes to infinity. 3 times infinity is infinity, minus natural log of infinity is infinity, and that's because the natural log function goes like this. And as you go out to infinity, this keeps on getting bigger and bigger. It doesn't go very fast, but it does get bigger. As you go out to infinity, this thing goes up to infinity. So natural log of infinity is infinity. So we have infinity minus infinity. Now, what we'd like to do is, or what I'd like to do is just remind you, these are the things that are bad. 0 to 0, that's bad. We have to do something. But those we can do L'Hopital. We just said earlier 0 times infinity is bad. We got to figure it out. So is infinity minus infinity. In fact, you had a problem on your test like that. So the question is, what can we do to try and somehow maybe turn this into a product? Let's go for it. Okay, let's see if you agree with this. Is this the same as x times 3 minus natural log x over x? So what I did here was I factored out an x. So if I distribute that through, I get 3x. I had to put an x down here under natural log so that when I put it through here, that it would cancel and just leave me with the natural log x. So if you believe that, then if you believe that, you can factor an x out, then that's the same expression. Now as x goes to infinity now, this goes to infinity, times, now in parentheses, 3 minus, now what happens here? Natural log of infinity is infinity, divided by infinity again. So check it out, just this piece, let's focus all of our attention on just this piece, and let's just do like a little scratch work side problem. What is the limit as x goes to infinity of just that, natural log x over x. Well, we already know it's infinity over infinity, so let's apply L'Hopital's rule and see what happens to that little guy. Derivative of the top is 1 over x. Derivative of the bottom is 1. So this is the limit as x goes to infinity of 1 over x. And that's a fixed number divided by something that's becoming infinite, which goes to 0. So what I know is that this right here heads to 0. So what we have happening is that this was going to infinity, and then in parentheses, I had 3 minus 0. So that's the same as 3 times infinity, which means that this thing is going to infinity. So the answer here would be infinity. I'm very curious to see how they did that one. So let me see. I wonder if they used exponents. Nope, they did the same thing. Yeah. Okay, so that's what they factored an x out and did L'Hopital on that little piece and then said that's 1 over x, and that came out to be 0, so that was 0. And okay, not a whole lot of information there. Not surprised. Was that the whole thing? All right. That's it.